Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Lecture 3, Chapter 3. This is what we are going to go through. So, this is the one. Okay. So, in case of Lecture 1 and Lecture 2, where we covered several things about Chapter 1 and Chapter 2, we are starting yet again another lecture, another chapter, where we are going to study more about use cases and threads. And you have already seen example usage of threads, and your assignment 1 was based on an example scenario where you have to synchronize some threads. Okay, the chapter for this session has been taken from this book by Daniel Young. So this is a Java programming book, not necessarily concentrating on concurrent programming alone. It has many aspects of Java. One of the very useful chapters in this book is about multi-threading and Java concurrency control. So definitely it is going to be a useful chapter as well. We have already seen example of how we used Java threads, and everything started from chapter onwards, chapter 3 onwards, all the practicals. That is just going to be an example that we are going to use. You are not required to create programs that have similar setups. So whatever we have learned in chapter 1 and chapter 2 is what we will do in terms of programming. After chapter 3, whatever we are learning in terms of programming is just for your knowledge, and you can try and practice them, but we are not going to test you on that in the exam or in assignment 2. You have to still know areas of codes where you do things. You don't have to create fully working programs. That's the difference. Okay, so in chapter 3 we will cover several aspects of thread pools, how we can create pools of threads when we have many tasks to do, how do you synchronize again on thread synchronization, more details of thread synchronization, and logs and synchronization, cooperation among threads, these 4 areas. Okay, again we have this assumption in this module, which means you are an experienced developer familiar with object-oriented programming, and if this is not the case, you will have difficulty learning this module. You need to go back and learn some Java if you want to do the assignment and understand several extreme examples we are doing here about concurrency control. Anyway, you may as well survive with a little knowledge of Java if you try really hard to cover the basics. Okay, so in case of thread pools, what is happening is we have the ability to create pools. You can see here in this example we have a number here, which means creating 3 threads, for example. In case if you want to create many threads, what we have been doing is we have been creating them separately. So now we have the ability to create threads with one line. How many threads do you want? 3 threads. So it's kind of easy when you have one line which gives you more threads, something like that. You can assume that way. This is the example we have seen where we were creating a thread, and then we were implementing this java.language.runnable interface, and by implementing the interface we were able to create a run method, and in the run method we execute what we want to execute, right? That is what actually informs us that there is a runnable object that can be passed into our task class. So this is what we did. We created several tasks using the task class. In our example that we did in the classroom, of course, we created what we called as a project cache manager, which was you can say a runnable interface. It implements runnable interface, therefore it is fit for use as a task. So you can actually pass it into a thread like this. So this task 1, task 2, task, it can actually be passed into a thread like this. This is what the runnable implementation allows you to do. But we created 7 tasks, and you can see here they are all individual tasks, and then we have these individual tasks created. Again we have to separately start them. Although you have separate line for them one by one, they actually have simultaneous execution. So you have to remember the lines, the order of the lines doesn't really matter when it comes to thread. Okay, convenient for single task execution, not efficient for a large number of tasks. Okay, so the idea is when we created like this one task like this, where we created a task and started the task, that is useful when we have very less tasks, like 1 or 2 tasks or 3 tasks. Even for these tasks, it's way too much. When you create 1, 2, 3, 4, 5, 6, 7 threads, it's not useful. So it's not convenient when you have large number of tasks, because you have to create a thread for each task, you know. So it could also limit the throughput and cause poor performance of the system CPU. So a thread pool is the solution to this kind of problem. So in order to create threads and manage threads, multiple threads, the answer is thread pools. So a thread pool, you should know this definition. A thread pool is ideal to manage the number of tasks executing concurrently. Okay, that's not really a definition, but that's what a thread pool does. Okay, so in Java you have this executor and executor service available. Java provides the executor interface. So here you can see this is the actual interface, which is the executor interface for executing tasks in a thread pool. And then you have this executor service, which is also an interface. You see, this is an interface and this is also an interface. So executor service interface for managing and controlling tasks. So you have this one which can actually manage the tasks, and also you can see here's a sub interface. So executor service is a sub interface, meaning it extends this interface, is a sub interface of executor. So this comes from this class, and by extending these features it has several other separate interfaces. So the executor that is up here is the parent interface. So the executor executes the thread, and the executor service manages the threads. Okay, so this is what you use when you want to execute a thread. Executor service is what you use when you want to manage the thread. So you should understand in that way as the relationship. So the runnable object is executed by the executor, but when it comes to management, then you need these methods like shutting down the executor, shutting down a runnable task, shutdown now, shutdown is terminated, example of methods that can return to you if they are shut or if they are finished, completed. So remember these words and these definitions and keywords here, very important. So executors, to create an executor object, you use the static methods in executors class. This is not the same class. Remember, there's a class called executors. In previously it was executor. So this is an interface, and this is an executors class. So to create an executor object, you use the static method in the executors class. So what it does is it returns executor service. See, if you create a new fixed thread pool method, it's going to return, it's a static method, meaning the class is a static class. So if you have a static method, you can directly execute it using the executors class name, and then this returns an executor service to you, which means you have the ability to control it. Or you can use this second method, which is called new cache thread pool, which is also going to return an executor service. The difference is here you give number of threads you need, here you don't give, meaning it creates the thread pool, it creates new threads as needed, but we will use previously constructed threads when they are available. So this is a better way of creating threads. So the executors class provides static methods for creating executor objects. You see, these definitions and simple things you should remember. Okay, so if a thread completes executing a task, it can be reused to execute another task. That is the case. If a thread terminates due to a failure prior to shutdown, a new thread will be created to replace it. A thread in a cached pool will be terminated if it has not been used for 60 seconds. Okay, so it saves more resources, kind of. Okay, so here is what we were saying. You will use the executors, executors class in order for you to create a pool. For example, if you want 3 threads, you can use new fixed thread pool function, and this is going to return an executor service object. Okay, and you will assign it into the executor, and of course this is an executor service object which you will use, and it has the execute method. You can see here it has this execute method because it extends the parent class, and when you return an executor service object, it has this execute method inherited from the parent class. Therefore it can use this execute function. You could have called this method anything you wanted actually. So executor function executor calls the execute function to run this task, to run this task, to run this task. Still, you can see you have to separately give those task numbers. You don't have to create the task, but still you have to say execute this task, execute this task, execute this task, because these are all runnable objects you are passing into the execute method, and in turn they will actually run their run method, right? And then you have to shut down the executor. Okay, here you have this executor, you have to shut it down, because after you are done you have to shut it, you are not going to need it anymore. This one is the same as creating one thread, for example, but the difference is, if you want one thread, of course you will use executor service execute equals to new fixed thread 1, instead of 3. What this does is the 3 runnable tasks will be executed sequentially. So remember the impact of this. If you have 3 tasks, they can be run simultaneously, but instead if you have one thread, of course if you are running everything using one thread, then they are going to be run sequentially after one of them is finished, because there is only one thread in the pool. So if you create a pool, you have to give the number, or you can create this method. You go for cache thread pool without giving a number, and that is going to create new threads as needed. New threads will be created for each waiting task, so all the tasks will be executed concurrently. Okay. All right. We have seen thread synchronization in lecture 2, in chapter 2, but again we are revisiting it because we wanted to come back to this concept of the synchronization in a more detailed manner. So synchronization is important because of shared variables. When you are sharing variables, when you are sharing items, you don't want to end up in a scenario where incorrect results are produced because of sharing. And this is what we did in our example about the budget case, where we created a synchronized block. So this is our method. We are synchronizing just this block. This change in the budget is being synchronized. And if you read a little bit, or if you see in the examples, you can actually move this synchronized keyword into the method, making the method itself synchronized. That's also fine, but this is more fine granularity, because we are saying exactly which part should be synchronized. Okay, so you have seen how we have done the resource sharing, an example. Look at this example. We have a shared resource called received amount. Look at this class called donation. So if you are donating some money, if hundreds of people are donating money to a fund, for example, so that fund is having let's say a shared variable, which is the amount that has been received. So you have to make sure that you get a received amount and you synchronize this amount. In order to make sure when you get a new donation, you have to make sure you update this accordingly. So let's try to simulate a scenario where, for example, suppose that okay, anyway, so what is the issue here? The actual issue is because of the shared resource. A shared resource may be corrupted if it is accessed simultaneously by multiple threads. They have to access it in a way, when one thread is updating the value, you shouldn't access it. You should wait until the update has been finished, because you are about to read something updated. So if someone already donates some money and that is the balance, you can only increase the balance by reading current balance, and that is only true if you know the current balance. So that is if you have a simultaneous execution, that problem may arise. Suppose that you create and launch 100 threads, each of which adds $1 to the donation fund. So let's say we have this is the fund. So basically donation is what it does. For every donation you have an amount that you are sending, and we have this football fund we have opened up, and into the football fund we are just going to donate $1 every time. So we are going to make 100 sample donations, and every time we will, for every thread or every individual, like a person who is donating money, so we are donating just $1. So this is how the donation class look like, and this is how our donation implementation looks like. And when we run the program like this, what will happen is there is no synchronization, and therefore without synchronization you will end up in a case where there is corrupted football fund balance. This received amount will be corrupted because all of them are accessing and reading the balance at the same time. So how do you do that? Okay, again, there should be the main program where you're going to do the handling of these 100 threads. So we can't follow the method we have used where we created 7 threads, for example, in our case. So in order to simulate 100 threads, the best way is to use thread pools, and that is the reason why we said we can use pools. So in the exam you are not going to be asked, or in the assignment too also, you're not going to be asked to create these lengthy programs, but you should know how, where and what to be added, how it works. you know you should know, of course, a class, what is a constructor, what is a private variable, what is a getter, what is a setter, what is a member function. You should know how do you implement the runnable object and the implications of it, because if you implement runnable, you must implement this run method. Those things you still need to tell us. You should know them. And also, this is an additional method you have created and it has a static in front of it. By that also you should know what it means. So those are some of the important things that you should know from some basic of Java. Okay, so you have this main class which is creating demo of this system, where you create 100 tasks using cache thread pool. So that means whenever there is a new task, it will automatically trigger a new thread. So you have 100 concurrent threads running, and you are going to do a for loop to make sure you are going to run this 100 threads. So every time it goes back and creates a new make $donation. So what it does is, here it runs this method called make $donation. It creates an object, and by creating an object you are running this. You see, you are donating this money. Okay, because you say execute, therefore it executes this task, and the implication is it goes and runs the run method. Therefore the run method says donate $1, therefore it will make football fund donation of $1. Like that it goes on, and then we are going to shut it down, because as I told you, it's just like the executor example here. We are going to use executors class, and we are assigning it in the executors service object, and this item was called executor in the example you saw earlier. We are calling it task handler. So task handler dot execute. So now we have to shut down the handler, because we have finished using 100 threads and we are not going to use it anymore for now. So if it is terminated, then we will end it. The reason for having this while loop is you want to absolutely make sure that it gets terminated, and once it is terminated, then you are going to show the balance of this donation account. So if you try this multiple times, you'll get wrong answers. Instead of 100 to be 92, 95, 97, like that it goes on. Okay, so this is the solution to this problem. Again, we have used the same example previously using that cache example. You have to synchronize the football field that you are using, the football fund that you are using. So you have to synchronize a block. You can synchronize a block of code separately by entering the synchronized keyword. you know so you can see here you have the synchronized keyword. See, in the this case you have run method, and then you have this synchronized method called auto donate, and this is one example of how you can do this. Or because we are executing a donate function, we could actually make this donate function as a synchronized function. So you can either do this by putting the synchronized keyword in the run method, so that it accesses them by by locking. It will always lock the variable before it executes, and it will unlock it after it is done. That's the purpose. So you have here the football fund which is being synchronized, so every task knows someone else is using it, therefore it will wait until that task finish writing the update. Or you could do the deposit method synchronization by adding synchronized keyword in front of it. It's the same, because you are executing the donate function here, right? So you can either synchronize this block, or you can either synchronize this method. Both of them results in the same thing. The difference is where you are putting the synchronized keyword. Okay, it's not synchronized, remember, synchronized. So remember that. Okay, some students actually make that mistake. And you have to pass a variable if you are doing it as a block, but you don't have to pass a variable if you are doing it in a method. Okay. So to avoid race conditions, it is necessary to prevent more than one thread from simultaneously entering a certain part of the program known as the critical region. This is why we are making synchronization. This is why we are causing this to be synchronized. So you must be able to answer in this kind of context. We say to avoid race conditions, it is necessary to prevent more than one thread from simultaneously entering a certain part of the program known as the critical region. So what is the critical region? That also you should be able to answer from this same example or from previous examples. Okay. Another way we could do synchronization, which we haven't seen previously, is using locks. We can lock, we can unlock, and those kind of things. So the lock class provides us with the lock interface actually provides us with these kind of methods. So let's have a look at there. So we were using synchronization previously, and they themselves use actually locks, but locks can also be used manually. So you have here this lock class, and we have a sub interface of the lock class called re-entrant lock. So it also has the lock and unlock condition available, plus it has its own re-entrant lock. So the locks are actually by the lock class, and the re-entrant lock, for example, implementation itself is known as a subclass of this, a sub interface of this interface, and it creates a lock with the given fairness policy. And when the fairness policy is true, the longest waiting thread will get the lock. Otherwise, there is no particular access order. So there's the difference. You can define who gets to access first. So how do you do that if you are using locks then? So if you are using locks, the implementation looks a little bit different. You will create this lock here. Instead of creating the synchronized keyword, you need a lock. So you use the lock, and then you execute the lock command on this variable. So you say lock.lock. Now you carry out what you have to do, and you have to do a try catch block, because when you are locking this variable, if something happens during the lock or while you are running, you have to be able to make sure you catch it. So this is the standard way of using a lock. You will lock, you will do try catch, and then you'll have a finally block. And because we need to lock, we need to unlock this lock. We must have this finally block. That's the reason why we can create a try catch and add this finally block. Finally block gets executed anyways in a program. So which is why we want to make sure that the finally block actually releases this lock. Okay. And this is the final topic of this chapter, which is cooperation among threads. When you have many threads, how do they tell each other about themselves? So you can have the await method, for example, that waits, signal method that signals, and signal all method that signal all the threads. Wake up all waiting threads. So let's have a look at an example. You must know a little bit of what the method does actually. Okay, so cooperation among threads refers to thread synchronization among the threads altogether. So thread synchronization suffices to avoid race condition by ensuring the mutual execution of multiple threads in a critical region. Sometimes you also need a way for thread to cooperate. When you have more than one threads and they are working on a critical region, you want them to cooperate with each other, talk to each other, exchange messages. So conditions can be used to facilitate communication among threads. Okay, you can actually enable that. For example, suppose that you create and launch two tasks, and one task deposits some money to an account, and the other task withdraws some money from the same account. And for the withdraw task, there is a requirement, and the requirement is withdraw task has to wait if the amount to be withdrawn in the money is more than the current balance in the account. So it has to wait until there is enough cash in the balance, or it will fail. Okay, so whenever new funds are deposited into if the wait method is waiting, and if there is a simultaneous deposit task going on, then it can wait. In this case, whenever the new funds are deposited to the account, the deposit task notifies the withdrawal thread to resume. Okay, okay, so it allows the threads to be resumed, and therefore the thread knows, okay, the information end is here, now I can continue. If the amount is still not enough for a withdrawal, for example, again the withdrawal task will the thread will continue to wait for a new deposit, like this for example. Okay, once you have a lock and there is deposit going on, you can actually ask to wait, like if the balance is less, this is a task, so we will say wait, and this deposit is a condition actually. So you have this condition called private static condition new deposit. So this new deposit refers to a condition, and that can be used in order to request others to inform you. So you are saying new deposit dot await, so it means I am waiting for some people. And then here is the rest of the code, and because the deposit task is sending money to the account, it can proactively tell others I have deposited money. So it has this additional balance deposit, and then it will signal others, hey guys, I have deposited some money in this account, try withdrawing, something like that. So signal all await example of communication between the threads, and that's not how they do it. For example, in order to signal, it will have this it has this lock, it has the lock release also, but it has this waiting. Why? Because the balance is too less. So it's say I know I have to run, but I'm waiting. And then when these other tasks that are running informs the tasks, like using the same condition, see, new deposit, same condition, and they are signaling all, whoever is using the same condition will get notified, so signal all after doing this, so that they can continue executing and don't wait. All right, so this condition has to be the same, those releasing the resource and also asking to await should be used the same condition statement, and there's a class called condition. Okay, okay, so that is the idea of how we use wait statements and communicate with using signal all, for example. Okay, so anyhow, when you are using this method, there is some caution, you have to be important things you have to mention in your mind. Once a thread invokes the await on a condition, the thread is put to wait for a signal to resume. You see, this withdrawal wait will wait and wait and wait. So if you forget to call the signal or signal all, for example, if you didn't put the signal all method, then the thread will wait forever. This is not correct, right? So you have to remember, in a multi-thread application, you have to stop this task. Okay, and the caution here: a condition is created from a lock object. To invoke its method like await and signal or, you must first own the lock. So that point is important. If you invoke these methods without acquiring the lock, illegal monitor state exception will be thrown. So these simple basic readings you have to remember, read a little bit, make sure you understand a little bit. Okay guys, so that is the idea of what the lecture chapter 3 is about. Okay, so see you in the class.